So we're here with Matt Williams from Pennsylvania State University at the Centro de Estudos Interdisciplinares da Universidade de Coimbra, CEIS20. Matt is our esteemed guest for our lecture series on a variety of topics that touch interdisciplinary research. Matt, it's a pleasure having you here.
It's wonderful to finally meet the man, the myth, the legend, Dr. Teixeira.
Well, I'm not sure about the myth and the legend. So Matt, welcome, and we would like to start basically, if you can tell us a bit about who you are, what's your background, your research focus, and a research trajectory.
Okay, so background is in ancient Near Eastern history. Where I studied at Macquarie University in Sydney, and it was there that I first got a lover or captured by the ancient Near East. There's just something, there's some like mystique, mystical, beautiful aspect of the ancient Near East, particularly Mesopotamia. And so a few lectures really just got me hooked. I had the opportunity then to go on some excavations in Israel as well during that time. And then from there I went to Canberra to do a master's in archaeological science. I really wanted to explore the methods that we could use to begin to interrogate migrations, timing of particular events. And that was at the Australian National University in Canberra. And it was at the ANU that my professor introduced me to ancient DNA. And so I had then the opportunity to take a couple of classes in genetics. And he also then encouraged me to reach out to Alan Cooper at the Australian Centre for Ancient DNA in Adelaide. And so there, we got in touch. I got in touch with also Wolfgang Huck and Raymond Tobler. Came over, did an internship, did a project there for my master's, and then wound up doing a PhD. And so that's been my journey from history through archaeology to ancient DNA.
And now you're at Penn State, and so that's...
Now Penn State.
It's really interesting because we've talked about a lot, and this center specifically focuses on interdisciplinary research. And I realize it's a big buzzword these days. Mm-hmm. But you're actually here showing us that you could do interdisciplinary research by navigating also across disciplines. But maybe tell us a bit how, more than multidisciplinary, how is your research interdisciplinary? What kind of dialogues do you establish, and what are the main challenges in doing interdisciplinary research?
So I think the interdisciplinary nature of ancient DNA begins with the questions. A lot of the questions are, at least in my case, at least from my story, the questions are motivated by understanding history and understanding the past and understanding human movements. And then it's interdisciplinary because of the object in which we're studying. We're studying ancient human populations, and humans are composite creatures of culture and biology. And so to properly understand the nature of ancient human societies, you need to incorporate data and inferences from multiple different disciplines. And so from my perspective, it was originally driven by the questions, which were sparked during my undergraduate years and my master's. Say, for instance, during my undergraduate, I became aware of an ancient Judean exilic community living in Babylon during the 6th and 5th centuries and 4th centuries. And so these individuals that were taken in captivity from Judah, relocated into Babylon, and have their own little ghetto community. And you have marriage contracts and text written in Babylonian, in Akkadian. And they document the marriages between different individuals within these communities. And these individuals then have names which carry what they call these theophoric elements, so these divine elements within a name. which gives some level of like socio-religious affiliation of that individual, at least the individual's parents. And so that's what like really interested me about ancestry. So what happens when you have someone with a Judean name marrying someone that has a Babylonian name? Or even there's an interesting text from an ostraca called the Lachish ostraca, I believe it is. And this is an individual that they've identified as having Judean name, but in a seal, it also shows him, which it looks like he's worshipping Babylonian deities. So he's Judean, sort of religious affiliation by name and by family, but practicing Babylonian religious traditions within his administrative and economic activities. And so there's like multicultural, potentially multi-different ancestry dynamics occurring within populations. Is like what drove my initial fascination with trying to understand migration and ancestry. And so the prospect of ancient DNA and the prospect of interdisciplinary research, I think, is being able to then take these various lines of evidence and properly synthesize them. That's where I think, for me at least, that's my idea, or my ideal of what truly interdisciplinary ancient DNA research could be.
Yeah, it's interesting. I think it does go beyond the ancient DNA. So I think, research in general always starts with questions, or it should start with questions, and not just like more of the same in industrial fashion. Even though we know that's what gets us jobs and grants these days, is if you embark on a factory-style production of knowledge. But so for me, and I sympathize with that argument, because I didn't think about interdisciplinarity from the get-go, right? It's something that happened to me while pursuing questions that I'm interested in. And here at the center, it's really interesting because people study arts and education, and how can you, for example, bring scientific research, transform it into like an art form, and how do you communicate that to the public, for example? How do you teach that at schools? And so that requires communication across disciplines, and it's complex objects that people are usually interested in, which you also mentioned. But what do you think? You mentioned that the goal would be to synthesize somehow this information, and would you consider that a main challenge?
Yeah, I think so. And I think one of the big challenges there can be that when you have silos, when you have disciplinary silos, you have languages and perspectives which are sort of entrenched within these particular silos. And then oftentimes you can have like competition between interpretations of the past. And I think in some instances there can be true competition in interpretation of the past, but I think a lot of the cases it's just a misunderstanding of two different or multiple different disciplines in what the complementary or opposing discipline is actually saying. And there's a concept from philosophy where you want to make sure that your arguments are cogent, that your conclusions follow from the premises. And I think sometimes a lot of challenges in interdisciplinary research can be where your conclusions slightly deviate from the niche in which your data and your premises emerge. So, for instance, a lot of the conflict between ancient DNA and archaeology in the beginning is with the idea of migrations, and how much do migrations contribute to our understanding of various patterns that you might see now in the archaeological record. And in one perspective, genetics is the primary mechanism by which we understand that two individuals have mixed, or two populations have mixed and continue to produce offspring. But in another sense, it's an indirect measure because there's no geographical information encoded in genes. You're just looking at frequencies of genes or looking at haplogroups or whatever. Whereas in archaeology, you could use like bioarchaeological methods like stable isotopes, where you can get like a coarse understanding of migration. So there you have more a direct estimate. or a direct measure of individuals moving from one location to another. But in the other sense, it's an indirect measure of the impacts of migration, because pots don't equal people is the phrasing which has sort of emerged through some early archaeological debates or archaeological theory debates. And you don't actually know if the individuals that migrated, you have no true measure of like their kinship structure, where the individuals actually mix within the population, whether they were just single generation migrants, which had no impact on the preceding or descending generations. And so sometimes I think if you make an argument from genetics about changes in material culture, well, that's perhaps stretching things a little bit, because your genes tell you nothing about the parts that you're making. Mm-hmm. And likewise, I think if you see shifts in material culture or no shifts in material culture, and you have maybe a predisposition or a entrenched argument that there could not be migration, well, your pots aren't telling you anything about the mixing of individuals. And so I think when two camps become too ingrained in their disciplines and don't allow for the types of data that they have to be used as explanations or inferences about that specific type of data, with reference to that specific type of data, I think that's where some of the challenges can emerge. So I think moving forward, particularly as the data sets get larger and our resolution increases, moving forward, I definitely see one of the main challenges as being forming perspectives that can properly synthesize the two different types of data sets to produce a holistic understanding of past human societies. And that can have an impact on understanding theories of migration, understanding why people migrate. And so there are nuances that will emerge through a proper synthesis of these two types of data sets that can be more informative about the nature of human societies and why people mix and why they don't, and why culture changes and why it doesn't. But I definitely do see that as one of the big challenges of the future, particularly as the data sets continue to increase in size and resolution.
Yeah, I fully agree. My experience is that those sort of misunderstandings or sometimes even petty competition between fields, which, I mean, it's petty and it's understandable in the sense that there are limited resources for research. Yeah. And so, and that creates, so that's the nature of scientific research funding, that also fosters those types of divisions that make no sense, because we're just trying to understand the past, sometimes through different lenses, sometimes through integrated lenses. And I think that I'm just to add to what you said, which I agree with, is that one of the things I've learned here is that it's the power of actually, and my own research delves into this, it's the power of, trying to understand what the questions are from, for example, in my case, from an archaeological perspective, what are interesting questions? And how can genetics, which is my own tool of specialization, how can that actually answer those questions? And can it do it? Because sometimes it's not possible. And so one of the challenges I find, for example, is in the communication of what is possible to do and what not, which takes me to my next question, because the title of your talk here is how you can use the ancient DNA. What can we know and how can we know it? So can you tell us a bit more about that?
Yeah, perhaps we should have rephrased this as what can't we know?
Oh, what can't we know?
Why can't we know it? Maybe that should have been the title.
It's fair enough.
There's an analogy that was very helpful for me early on, and that's with the radiocarbon revolution. So you have Willard Libby discovers that we can use the proportion of C14 to date organic material. And you have this boom in archaeological research of we now have absolute dates rather than relative chronologies. And particularly as a graduate student, when I first learned about radiocarbon dating, I was wide-eyed, star-eyed, this is amazing. Look, we can date all these things. How cool is it going to be? And then you realize, so there are a few analogies, I think, for ancient DNA that are interesting. One is that you realize that for some questions, the error bars in your radiocarbon dates span a time period that's greater than the questions that you have of interest. And the other is that there are periods in the calibration curves that are flat because the changes in atmospheric conditions result in the same proportion of carbon-14 throughout time. One of them in that first millennium, of particular interest in the first millennium, I think, is the Hallstatt Plateau, and particularly with the late Bronze Age to Iron Age transition for the Southern Hemisphere. And so you come in thinking, okay, we've got this great method, radiocarbon dating, we're going to be able to resolve chronologies, we can resolve ascension years for kings and queens. We can time the migration of particular individuals to a region or changes in material culture. And then you see like, there's this window of time whereby, whilst we have this tool which is amazing and can give us absolute dates, there's just, because of the nature of the universe, we just can't. Now, there are additional methods like incorporating stratigraphy and some other approaches that allow you to like tease out some of the minute changes, even though you have this fixed proportion of radiocarbon. But there are nonetheless elements of our world which minimize the power of these methods to resolve questions. And the analogy is that in ancient DNA, there's the same thing. So we may have two particular populations that are culturally very different. They may have completely different perspectives on the world and have completely different impacts on people surrounding them. But because they split from one another tens of generations ago, in terms of their allele frequencies, they're identical. And so we're almost identical to within some degree of error. And so we can now no longer tease apart who impact who genetically because they're extremely, extremely similar. And so that has helped me see that there are challenges. Whilst ancient DNA has had its boom and it's had its its initial revolution on our understanding of the past, as we move into the historical period where there's much more population similarity, there are more groups which we're trying to co-analyze to answer specific nuanced questions. That's where I think we move into our own radiocarbon plateau for ancient DNA. And that's where things can get challenging. But that's where new advances, newer techniques, thinking carefully about different ways to approach these questions is going to be an important advance. And then the other one for me that was challenging in the interdisciplinary communication aspect is that the two disciplines use different languages with regards to like population, like something as simple as population size. It actually was a little bit, it took me a little while to really get my head around effective population size. I think coming from from a archaeological historical background where we're just thinking about the number of individuals that are present in a community that are moving from one location to another. This idea then that in population genetics, you're principally working with measures of diversity, and those measures of diversity are, or what they can tell you about the relationship between populations is really based on these idealized populations, whether it's coalescent effective population sizes or mating effective population sizes, and really just internalizing that the language of the size of a population is different between the two disciplines was something that obviously I wasn't prepared for and took a little bit of internalizing. But those are two examples of things that I personally have found helpful and challenging in truly internalizing the language and concepts of two different disciplines.
Yeah, no, that's cool. I have my own. So for me, it's the fact that I have to always explain that if you have the access to the genome of one individual, it doesn't tell the story of just one person.
Right?
That you can learn the story of a population if you have one individual. And so it's I guess it's a mirrored problem to what you just brought in terms of what is a population, and like the fact that geneticists deal with this abstraction of idealized populations and measures of diversity is really what we're talking about in terms of effective population size. When we talk about individuals, right, for the archaeologist or the anthropologist, it's usually one person and the story of one person.
Yeah.
And for a population geneticist, it can just be the story of a population, because it is possible to get at those aspects. And so it is, but at the same time, what I find, and I don't know about you, but what I find enriching is in this is that by learning how other people think, that actually enhances a lot how I'm phrasing the questions. And it's opening my mind to questions that I didn't think were there, because I wasn't just aware of that knowledge. And so can you tell us a bit more now specifically about the research you're doing right now? So what are the main projects you're working on at the moment?
Yeah. Just before I go to that, the recombination aspect is really fascinating, because that's another element that population genetics has really opened my eyes to, is that when you're looking at ancestry, you're not looking at ancestry of individuals, you're looking at ancestry of loci, alleles. And they have their own history, and their own history can be completely divergent. So an example that I like to use is that, so I'm the offspring of a Jamaican father and a white Australian mother who has sort of their Scottish lineage. And my wife, she's the offspring of Finnish mother and British Australian father. And it's quite funny when you think that the variants that are inside my 2 chromosomes, the chromosome that I got with my mom has more recent ancestry than with for many of the loci with both of my wife's chromosomes than it does with the other one inside me, even though it's inside me. Like, it's my own heritage, it's my own history, it's my own parents. Yet these variants have more recent ancestry with my wife's variants than it does with the variants that came from my dad. Or at least the deeper African variants within his genome itself. And so recombination with this shuffling is like, it takes you away from viewing ancestry as something which is static and fixed in my genealogical past, and moves you to something that's quite fluid and dynamic on units of ancestry, which are have their own histories and their own divergent histories from the variants that can be right next to it. And I think we've had many discussions about this and how enlightening. In fact, we did a paper together for discussing these kind of issues and these kind of challenges.
Right. I mean, I just wanted to, before I let you answer the question, just to add to that, it's fascinating listening to you describing this, because so for my PhD, I studied shared polymorphisms between humans and chimpanzees, right? And what you're looking at is really parts of the genome where some humans, like ourselves, right, we are more closely related to some chimpanzees than we are to other humans, right? It's because because that segment of DNA, if we trace the history of that segment because of recombination, right, because of this sorting of genetic variation in sexual reproducing individuals, that because of that fascinating aspect of our reproductive biology, you can then have parts of the genome of what encodes what you are in theory, at least biologically, right? And you know what I think about this. But at least from a biological perspective, what encodes what you are, you can be more closely related to a chimp than to one of your parents, right? In the other chromosome, even though this person is just your parent, your direct ancestor, and that blows my mind still today. Even though we're familiar with this, so I just wanted to add that, and that's millions of years of independent evolution, thousands of generations, and still those variants are there. Right? And it's I was lucky to have that as a project for my PhD. Anyway, but tell us, Matt, about your work.
Yeah. So Oh, we could we could just go on.
Well, we could.
But yeah, also,
unfortunately, this is a bit scripted. That's a bit of a shame.
Yeah. So a project that I've been working on recently, which came out of my PhD, was so I have these samples, and they come from the Bronze and Iron Age, and they come from a population that has not been well studied at all. But I am assuming to some degree that population from which they descend is quite complex with regards to its migration history. And so prior to generating the data, prior to asking these questions, I was always wondering, like, is their history too complex for these methods to understand? Or what are the limits of these methods? And how does complex admixture histories impact these methods? Does it cause any biases? And so from that, developed a project where we used simulations and varied the nature of admixture histories, population differentiation. We started with very, very simple models and then moved up to complex models to understand what are the impacts of these ancestral migration events on these methods, whether these methods break down, and are there any biases that emerge. So that project has only just recently been published, so it's done, and that's one of the things that we'll be just discussing, some of the results we'll be discussing in the talk. And some of the other projects I'm working on are looking at various ancient Near Eastern populations, for instance, populations from Mesopotamia, populations from the Levant, and looking at their genetic history, and particularly populations from, let's say, the Bronze and Iron Age. And then, working with archaeologists as we then co-analyze and co-try and understand the ancient DNA aspect, and then the archaeological and historical dynamic, and the archaeological and historical aspect as well. Yeah, so those are the projects that I'm working on, and then trying to think about new ways that we can use existing methods or develop new methods to improve the way we can infer the nature of the past. So there's some pretty exciting methods that are starting to come online that people are developing. One of the interesting questions for the ancient Near East and human migrations is a question that we're both linked to through another project, and that is this question of basal Eurasians. You have this standstill hypothesis that in populations that they migrate out of Africa have a period of time where they're perhaps occupying the Arabian Peninsula. They don't partake in the Neanderthal, or they're not the ancestors of individuals that were admixed from Neanderthals, and then they later mix with ancient Near Eastern populations, and you observe this decrease in Neanderthal ancestry that appears to be correlated with your proportion of these ghost populations, these basal Eurasians. So these are difficult periods to try and interrogate, especially when you don't have data from these populations themselves. So yeah, trying to think about ways in which we can evaluate how well we can answer these questions, and then can we say anything about the ghosts of our past is another thing that I'm really interested in.
Yeah, no, that's very intriguing indeed, and we've had informal conversations about this when we shared our time in Adelaide. Because these ghost populations are basically placeholders for stuff we can't really explain with current models. And one of the issues being we know the models are wrong anyway. They could be. We just hope that they are good approximations. Yeah. So, and you don't have to answer this straight away. Maybe you don't know or you don't have an answer. But what kind of credibility you give to the existence of these actual populations? Because, for example, for the archaeologists listening to this conversation, right? When you say there's a ghost population, there's a ghost admixture, people will assume, I guess rightly so, that there were actual people who carried a particular genetic background for which we cannot account yet for, because we don't have the material fossil evidence for their existence. So, or we do, but we don't have the DNA from those fossils, and so we cannot really pinpoint what population is. So, but geneticists use this interchange. I mean, we're totally comfortable in saying, oh yeah, there's probably ghost admixture.
Yeah.
And I'm, and you know this because we've talked about this, I'm less comfortable with making that assumption immediately because of some of the limitations you talked also about ancient DNA and so on. So do you want to expand a bit? What are your thoughts about the existence of these ghost populations? There are other ghost populations. I mean, we tried, for example, to look for in work we've done for admixture from super archaic groups, of course, with hidden assumptions on how divergent these groups would be, because we have no DNA for them, right? So all of these studies are interesting. I mean, I think, of course, my own work is interesting, but they are interesting questions and we can answer them to a certain degree, but they are still abstractions. So do you wanna expand on this?
Yeah, that's a cool question, because in some sense, every admixture signature that we detect, perhaps you could go as strong as to say that if not every, then almost every admixture signature that we detect is from a ghost population. Like if we sequence ancient individuals from Lisbon and we detect admixture signatures in North African populations from Morocco that carry some Iberian ancestry, the likelihood that we got the actual ancestors of the actual people that crossed the seas over to Africa is almost zero.
We're all looking at proxies.
We're all looking at proxies.
Right.
And so in some sense, every admixture analysis are tracing ghosts. And the question then becomes, how closely related are my proxy to my ghost that I'm looking for? And so with the case of basal Eurasians, the problem with basal Eurasians is we don't have very good proxies. And we have a giant hole in our ancient DNA sampling that is from Mesopotamia all the way down to the Arabian Peninsula, from anything that's remotely in the vicinity of when we might expect basal Eurasians to emerge. Which means that all of our surrogates are really poor estimations. One of the populations that sort of does stand in or has been used as a stand-in are these 15 or so 1,000-year-old ancient Moroccan individuals, which carry this Levantine-like ancestry, and so various publications have used those as a surrogate of trying to estimate this basal Eurasian ancestry. One of the interesting aspects of it is that there was a recent paper, and the name of the authors just slipped me, that was looking at the distribution of Neanderthal remains and climate models to estimate the most likely, so no DNA, to estimate the most likely place of highest Neanderthal human cohabitation. And Iran, in the Zagros Mountains, was like one of the spots that they identified as. Which is really interesting because Iran has the lowest, these ancient Iranians have the lowest proportion of Neanderthal ancestry, or the highest basal Eurasian ancestry. Right. So are our Neanderthals that we have ghosts, or surrogates of these deeply divergent ghosts? So I think there's a lot of interesting questions in this space. I would say that maybe what I would be most comfortable saying is that it's quite likely that populations from the Near East have ancestry from a group that did not mix with Neanderthals. Who, when, why, and how? That's for us to discover as a community in the future.
Yeah, I'm really looking forward. So maybe, and to wrap a bit this up, maybe you want to keep it to yourself. But is this a future research avenue we will pursue, or can you tell us about future avenues of research you want to pursue, and how can some of the issues we talked about, how can your research, do you think, can help sort of overcoming these issues?
Yeah, so definitely this is a future research avenue I'd like to pursue, and so I have passions in the deeper past and then passions in the more recent past, and the future endeavors to really understand the nature of past population societies and movements, I think, are applicable to both time periods, and that is whether it's through co-modeling, whether it's through simulation-based approaches, whether it's coming up with like really ingenious statistical techniques, but the co-analysis of the two different types of data sets I think is going to be really informative. So whether for the deeper basic Eurasian question that's looking at like lithic tool distributions, skeletal distributions, and taking advantage of some advancements that will probably be well tested within the next, say, 3 to 4 years from ancient DNA and population genetics, I think that will start to paint a more clear picture about what's taking place with human migrations out of Africa and interactions with Neanderthals. I really do think that incorporating the multi-dimensional types of data that we have from archaeology and geology and climatology and population genetics and ancient DNA will, if done properly and done in true collaborative style, will definitely reveal some interesting aspects. The challenge is that I think doing that research is not easy because it involves collating data sets and between different disciplines and groups to go after a question that will take some time. I thought about doing it myself and I thought it's just too much. It's too much work, and so you have to work with and there's nuances within the discipline. Even though I did some undergraduate and graduate training there, there's still like so much that I would miss if I was to ever try and take that on by myself. And so you can see, if you look out into the future, you can see how if you take these multidisciplinary perspectives on researching the past, that if they are interpreted in an interdisciplinary way that does leverage the benefits of each discipline and is aware of the pitfalls and limitations of each method, you can see how we're going to get like a really, obviously we can have discussions about how much does science converge on truth, and we've had discussions about this before, but I think the picture of what was taking place as human populations migrated out of Africa is going to become clear.
Well, I like your optimism. I completely agree. You said something there with, and we were trying to wrap up the interview, but maybe we'll keep going.
I'm happy.
We'll skip lunch.
This is lunch.
We're
lunch. Feeding.
Yeah. Oh, definitely. This is definitely. Well, I like to eat as well.
We're both dads now, so we need to eat when we can.
Exactly. There is something else that I identify that as a potential issue. Maybe I will let you elaborate if you want as well after, which is the fact that these enterprises are done sort of independently. And they're done independently because it's a lot of work to actually design and implement research projects that are where the sort of engagement between the disciplines has a sort of equal share. And by equal share, I don't mean that the research should have the same funding or the same input. It's just that the intellectual burden or the intellectual input, if you want, on the questions and how they are framed, they should have like a more egalitarian setup. And that is hard work because no one is interested in doing that. Why? Because you're going to have to sacrifice some papers and some grants, right? To be able to design a project that is truly sort of going after the questions that are, let's say, at least for the two of us, more meaningful about the past. Now, on top of that, there are other things, and I'm not being interviewed, so I can just put them out and then let you deal with this. There's gatekeeping, and the gatekeeping is not just sample gatekeeping, it's just not access to resources gatekeeping, or the technology, say big ancient DNA labs, but it's also theoretical gatekeeping. So the moment your sort of results are sort of going against established paradigms or dogmas, because science has dogmas. We like to pretend we don't, but we do. We shouldn't, but we do have dogmas. That and you're touching upon something that is dogmatic, which is how did humans come to be? And there are theories for this, and there are, very strong opinions about this, which are, of course, rooted on evidence, right? They are rooted on evidence. But the moment it's true for me, it's true across the board. It's not true for biology or anthropology, the human origins question. It's true for the origin of the universe, for physics, quantum mechanics. It doesn't matter. It's true across the board, which is when evidence starts challenging some of the pervasive or prevailing views, then that is an added challenge, especially for early career researchers. Yeah. And so I was just adding to what but I don't know if you wanna comment on this. You don't have to. You don't want to don't want to get in trouble.
No. It is a really good point. I suspect. So there's one approach where it's like, okay, can we completely turn the system of science on its head such that it's not the way it is? Unlikely. Unlikely.
But I'm not asking for it. I'm just saying that, actually I'm asking, sorry to interrupt, but I'm just saying, let's own and let's be true to the ethos of doing scientific research.
Yes.
Which is have an open mind about the possibilities.
Yeah.
And if the evidence is contradicting some of your long-held beliefs, then you need to question those. I mean, if you're not willing to question those, then you should be doing something else, right?
Yeah.
I mean, that's my. It's a strong opinion, but to me, this is very clear.
Yeah.
And so science is ruthless on egos, ruthless. We're just waiting for the next person to come along and improve or disprove or shatter our theory. But that's part of the joy, I guess. So but I'm afraid that especially if you go, and this is going to go on Twitter too, there's a sort of a group mindset, of perspectives that are being allowed. Then, it's hard to be a contrarian, but I guess it's also rewarding. But anyway, you go ahead. Sorry, I was interrupting.
Yeah, no, you're right. But just to stay on that point, I think that's where those that are genuinely passionate about interdisciplinary research, I suspect that they may have, and this is just a hunch, I have no meta-analysis to suggest that this is genuinely true, but a hunch is that perhaps those that are really pushing in that space maybe are less likely to be dogmatic on their particular theories. And so, maybe there's reason to be optimistic that as more and more people get excited about interdisciplinary research, that if there are conflicts, that it won't derail the research in any way. Another thing I think is beneficial, which we talked about at the beginning, is that a lot of the conflicts, I think, emerge through misunderstanding. So let's say, for instance, that I'm an archaeologist and I've surveyed the Arabian Peninsula and I find extensive evidence of human occupation stretching back 130,000 years. And then population geneticist comes along and says, well, actually, we have extensive evidence that suggests that there is a significant bottleneck around 50, and it appears that everyone who's present outside of Africa descends from the population that underwent this bottleneck around 50,000 years. Those aren't in conflict with one another, because your physical evidence that you have on the ground, whether that's lithics or whether that's bones, it's not really going to be bones in the Arabian Peninsula, you're going to be lithics, but those lithics tell you nothing about their descendants.
I agree.
And so those two, whilst on the surface it may be like, headline, archaeology and genetics disagree about when humans might. No, like they're talking about completely different. If you stay within the discipline and your conclusions are proportional to the types of evidence that you have to support them, then those two results, those two outcomes are actually super interesting and not contradictory whatsoever. It's like, wow, there's like presence of humans on a particular region, and now we've got to try and understand why it appears as if their ancestry, they're not a large proportion of the genetic ancestors of people that lived then outside of Africa post this 50, which involves like power analysis, like would we be able to detect differences? Would a population that inhabited this particular region, even if they were the ancestors, would it still look like this 50 KY bottleneck? So I think a lot of the challenges then come with like just being careful about exactly what your data, exactly what can be concluded from your data, and try not to stray too far. And I think one of the examples comes from one of the examples of doing this well actually comes from the evolutionary biologist, paleontologist Stephen Jay Gould, with his NOMA work, where you have early conflicts between the Catholic Church and the astronomers and evolutionary biologists working in the Catholic Church about how do you integrate these faith and science conversations. And so Gould has this NOMA, non-overlapping magisteria concept. And I think if you take the heart of that concept, it's just ensuring that you're making appropriate conclusions within the discipline in which that research is being done. So I think the NOMA perspective that Gould has, and he may have actually used it outside of that particular challenge, but I think it really applies to interdisciplinary research as a whole, and can, if used correctly, I think will bring really exciting insights into the nature of ancient human societies in our past.
Matt, we could be chatting for hours and hours, as we usually do when we're together. But I guess the fact that you just mentioned Stephen Jay Gould is a great place for us to end this conversation.
Yeah.
And maybe put it a pause, and we can talk about Gould and in other contexts and his importance for evolutionary biology, and how even though sometimes his thoughts are dismissed because other theories have or are prevailing. I'm not sure they have prevailed, but they are prevailing. I'm definitely, as you know, fond of Stephen Jay Gould. Yeah. So let's end the interview here, because that was a great note. Thank you so much again. This was our pleasure to host you here in Coimbra. Thank you so much for telling us about your research.
Thank you so much for having me. It's been a pleasure being here. Yeah, thank you very much.
All right.